In this video, we're going to prove that the product of two 2x2 skew symmetric matrices will result in a diagonal. Well, the first thing we need to figure out is, what does a 2x2 skew symmetric matrix look like? Well, let's start off with A equaling AB, CD. We want to find out what are the constraints on A, B, C, and D, if any. Well, A transpose, well, the first row would become the first column of A transpose, and the second row of A will become the second column of A transpose. But we don't want A transpose either. We want negative A transpose, which means I just multiply each entry by -1. Now, we want these two matrices to be equal. We want that matrix A is equal to negative A transpose, which is the matrix that I'm writing down now. And it must be true that A equals negative A. Well, A, B, C, and D are real numbers, and the only real number that equals to itself with a negative sign in front of it is 0. A must be 0. Likewise, if D must equal negative D, that implies that D is 0. Now, we want B to equal negative C. B to equal negative C, and we want C to equal negative B. Well, if I multiply this equation by -1, I get negative C is B, or B equals negative C. Exactly this one. So I don't need this anymore. I have A and D have to be 0. And whatever C is, B has to be negative that. So matrix A, well, A and D have to be 0. And whatever C is, let's call it R, B must be negative C. So that's what A can equal. And we see the form. What's on the main diagonal has to be 0, and the other two entries just have to be negative of one another. So we can quickly come up with another one. 0, 0, and I don't know, S and negative S. Yeah, sure, I could have put the negative S there. But these two numbers just have to differ by a negative sign. And they do. Okay, so let's get our hands dirty and see what A times B equals. What is 0 times negative R, R0, times 0S, negative S0. First row by first column is RS. The next one is 0. That's 0. And this one will be RS. Okay, and this is diagonal. And the theorem is proven. But let's just look at it a little bit more closely. This time, you're going to have the matrices A and B. They started off with zeros on the main diagonal. The product will have 0 on their non-main diagonal. And the entries will, on the main diagonal, they'll be equal, and that equal number, that is the numbers on the diagonal, will be the product of the two negated. It will be negative the product of the two. So that means if you had 0, 7, negative 7, 0, and you multiply this by 0, 4, negative 4, 0, you will get, multiply those numbers, you get 28, negate them, and on their non-main diagonal, you get zeros. And if you multiply these two matrices out, you will see that that's the diagonal matrix that you get. So, an interesting question now that I look at this, if you take any two 2x2 matrices where you have zeros here and you have any old numbers on the non-main diagonal and you multiplied it by another such matrix, will you get a diagonal matrix? And the answer is yes, you will. The entries on the diagonal will not be the same. Multiply these two out and you will see that. You will get, well, actually, I can quickly give you the answer. If you multiply these two, you'll get AD 0, 0, BC. Okay, so basically, it works out. You multiply those two, and it goes here. You multiply those two, and it goes there. And zeros elsewhere. So a couple of minutes ago, we completed the proof up here. You multiply two 2x2 skew symmetric matrices, you really do get a diagonal matrix. If you like videos like this, please subscribe to my channel, leave a comment, and as always, most of all, please watch and learn.